Good morning to my American, European, Australian, Indian, and the students all over the world. Today we are going to do the topic a question from collusion in two dimensions and work energy theorem from the subject physics of class 11. So we are proceeding to the question of the two dimensions, collusion in the two dimensions. So suppose this is the xy plane, this is our x-axis, and this is the y-axis. This is our origin. A body comes here of mass 1 kg and another body comes to the origin through the y direction and it is also 1 kg. This is having a velocity of 1 meter per second and it is having a velocity of root 3 meter per second. So this is having a velocity of root 3 and this is having a velocity of 1 meter per second. So now we have to find, according to the law of conservation of momentum, both the balls stick together after collision. So we have to find the final velocity, and after collision they move in a two-dimensional plane with the final velocity v, making an angle theta with the horizontal axis, that is the x-axis. So we have to determine v, that is the final velocity, and also since it's a vector quantity, so we have to also determine the angle theta, the inclination with the x-axis. So we will resolve this velocity in the x and y direction. So in the horizontal direction it will become v cos theta, in the vertical direction v sin theta. So now we are writing the equations according to the law of conservation of momentum. So it will be m1 v1. This is the initial velocity having mass m1 is equal to both of them after collision. They will collide and they will have the net. Both the masses will add together with the final velocity v and its component v cos theta. This is our first equation. Now the second equation, that will be m2 v2 is equal to m1 plus m2 into v sin theta. This will be our second equation. So now dividing the first equation by the second, so and substituting the values, so it will be 1 into and v1, that will be v1 will be root 3 in the horizontal direction. So in the horizontal direction it is 1 upon 1 into root 3 is equal to, it will become 2 upon 2, and this will be v cos theta upon v sin theta. So it will get cancelled, and here it will be 1 upon root 3 and here it will be cos theta upon sin theta. So now here it will be tan theta is equal to root 3. So theta is equal to 60 degrees. So 60 degrees is theta. Now we will keep this value in the first equation and determine the velocity. So it will be 1 into 1 is equal to 2 into v into cos of 60 degree, that is 1 by 2. So 2 and 2 gets cancelled, so velocity is 2 meter per second. So this is our velocity with which both the bodies after sticking together will move with the final velocity, that is v. So I think you all might have understood this question. So we are going to understand this question once more. Here there is a two-dimensional collision taking place in the x and y plane. The first body, that is of mass m1, and it is having a initial velocity v1 moving in the x direction coming towards the horizon, and the another body coming from the y direction towards the origin, it is also of mass 1 kg moving with the initial velocity of root 3, that is v2. So after collision, they stick together and move with a final common velocity. We have to determine that final common velocity v, and it is making an angle of theta with the x-axis. So we have also to calculate theta, since it is a vector, so it will have magnitude as well as direction. So it will be the first equation according to the law of conservation of momentum will be m1 v1 is equal to m1 plus m2 into v cos theta. This is our first equation. Second equation, m2 v2 is equal to m1 plus m2 v sin theta. Resolving them in the components v cos theta and v sin theta. So dividing the first equation by the second and putting the values, simplifying, we get tan theta equal to root 3. So theta becomes equal to 60 degree because tan 60 degree is root 3. So the inclination theta with the x-axis is 60 degree. Now putting this value in the first equation, we get 1 into 1 is equal to 2 into v, and v cos of 60 degree, that is half 1 by 2. 2 and 2 gets cancelled. So velocity, final velocity is equal to 2 meter per second. So this is our answer. Now we've also to calculate the loss in the kinetic energy. So we are rubbing this and calculating the loss in the kinetic energy. So the initial kinetic energy, that is kinetic energy initial with the suffix I, is equal to half of m1 v1 square plus half of m2 v2 square. This is our initial kinetic energy. Substituting the value of half into 1 into v1, that is 1 square plus half into 1 into root 3 square. So it will become half plus, it will become 3 by 2. So taking the LCM, since it's a fractional value, 2 is the LCM. So it is 1 plus 3, that becomes 4 by 2. So the initial kinetic energy is coming out to be 2 joules. Now the final kinetic energy, okay, final, that will be half of m1 plus m2 into v square. So now substituting the value in this equation, kinetic energy final is equal to half of 1 plus 1 into velocity, that is 2 square. So it is 1 by 2 into 2 into 4. 2 and 2 gets cancelled, so it becomes 4 joules. So the finding kinetic energy is coming out to be 4 joules. So our delta K, the loss in kinetic energy, will be 1 minus 2, that is 2 joules. So 2 joules will be the loss in kinetic energy. So I think you might have all understood this question also. So we are going to understand this question once more. We have to calculate the loss in the kinetic energy. So for that we are calculating kinetic energy initially it was having the formula for kinetic energy is half mv1 square. So it will be half of m1 v1 square plus half of m2 v2 square. So it will be substituting the values, it will be half of 1 into 1 square plus half into 1 into root 3 whole square. So it will be half plus 3 by 2. So it will be 4 by 2. So it will come out to be kinetic energy initial is going to be 2 joules. Kinetic energy final is equal to half of m1 plus m2 that into v square. V square is the final velocity which the body moves after sticking together after collision. So substituting the values, half 1 plus 1 into 2 square, so it will become half into 2 into 4, so it will come out to be 4 joules. So the change in the kinetic energy, the loss in the kinetic energy will be 4 minus 2, or you can say loss or the change in the kinetic energy will be 2 joules. 4 minus 2, that is 2 joules. It's not the increase, it's loss, it's the increase because the final velocity has increased, so it will be increase in kinetic energy will be 2 joules. So I think you might have all understood this question. So we are coming to the work energy theorem. According to the work energy theorem, work energy theorem. According to work energy theorem, the energy work done is equal to delta K, the change in the kinetic energy of the body, initial or final minus initial. So we are going to find the proof of this. Suppose there is a body of mass m moving with a velocity u, and its velocity has increased to v after some time. Then we have to calculate the change in its kinetic energy. So there is a body of mass m and it is moving a small displacement ds. The work done will be dw and the force applied in it is F. So dw is equal to F into ds. That will be F is equal to m into a into ds. So dw will be m into dv upon dt into ds. So arranging this, we can get dw is equal to m ds upon dt into dv. So now it will become dw is equal to m and ds upon dt is v, velocity. So it is v into dv. So now we are integrating this with the limits 0 to w. Dw is equal to m is constant, integrating from initial velocity u to final velocity v dv. So here the formula is, if we integrate v, it will become m and this will become v 1 plus 1 upon 1 plus 1, and the initial velocity is u to final velocity v. So it will become m and it will become v square by 2, initial velocity u to final velocity v. So it will become m v square by 2 minus u square by 2. So it will become half m v square minus half m u square. So it will represent the change in the kinetic energy, and that will be equal to the work done W. Here it will be W. So W is equal to delta K, initial kinetic minus kinetic energy minus initial kinetic energy. So this is our proof. This is coming out to be this, you can get. So this is our work energy theorem. According to the work energy theorem, the work done by a body in displacing by application of a force F is equal to the change in its kinetic energy. So suppose dW is the differential or the work done to by an force F in displacing a body of mass m with an acceleration a to a displacement small differential displacement ds. And according to work done, dw is equal to f dot ds. So it will be f into ds. So dw is equal to, putting the value according to Newton's second law of motion, f is equal to ma. So it will be m into a into ds. So dw is equal to m, putting the value of acceleration, that is dv upon dt into ds. So it will become m into ds upon dt into dv. ds upon dt is the velocity of the body. So we can write it as dw is equal to mv dv. So integrating it within the limits 0 to w is the total work done, and from the lower limit of velocity, that is v, to final velocity, that is u to v. Final velocity is v, initial velocity is u, mass is constant, so it is outside integration. So integrating it, it becomes v square by 2 with the lower limit to upper limit. Putting the upper limit and then the lower limit minus the lower limit, that is m v square by 2 minus u square by 2. So it becomes half m v square minus half m u square. That is the change in the kinetic energy. Kinetic energy final minus kinetic energy initial. So it will become delta K, the change in the kinetic energy, and that will be equal to the work done W. So our work energy theorem is proved. W is equal to delta K. So I think you all might have understood this question, this proving. So please watch this video till the end. Subscribe me and press the bell icon. Thank you.